Bismillahirrahmanirrahim. Today I wanted to talk about the parent quadratic function. This right here is the parent quadratic function. This is the most basic of all quadratic functions. Now what I've written over here, now these are quadratic functions too. Because if you recall, a quadratic function is simply a second-degree polynomial function. All of these are second-degree polynomial functions, but clearly this one over here even looks simpler compared to the other ones. Quadratic functions are only one type of functions that we shall study. Some other examples are rational functions, exponential functions, radical functions, etc. And they all look different. So quadratic functions are only one kind of functions that we shall study. And what we mean by a parent function is that it is the simplest function, it is the most basic function of that category of functions. So there are infinite different quadratic functions that you can make up, but the most basic one is right here, y equals x squared. And this function here is of great importance to us, because if you understand this function, that is, if you understand some of the properties of this function and how it behaves, so to speak, then you understand a great deal about the whole host of the same kind of functions. That is, if you understand the parent quadratic functions, you understand a great deal about quadratic functions in general. So what I like to do today, in fact, is to explore this parent quadratic function, y equals x squared. Okay, the first thing that we shall do is to plot it out. We're going to make a table, like we like to do, and then we are going to graph it. Now, I have written this function here as y equals x squared. Many times we use a slightly different terminology. For example, I could have said f of x is equal to x squared. Now this is very important. So let's say I gave you these three functions. All of these three, these are quadratic functions because they're second degree polynomial functions. And if I ask you, what's the value of y when x is 2? Let me repeat myself. What's the value of y when x is 2? Well, then we're puzzled because we don't know which y you're talking about, because they're all y's, but they're three different functions. So it's confusing this way. But if I call this one f of x, and if I call this one g of x, and if I call this one k of x, for example, then there's no confusion, because this function now has a name of its own that's unique. It's not y, it's f of x. Now this terminology, mind you, right here, this does not mean f times x like this. There's no multiplication sign hidden in there. In other words, this is one big variable. It's not two different variables multiplied together. It's just one big variable. It's f of x. It's not f times x. So the way you read this is f of x. Now this is very convenient, see? See, when I say f of 0, this means what's the value of the function when x is 0. And when I say f of 1, this means what's the value of the function when x is 1. And if I say what's g of 0, this doesn't mean g times 0. This means what's the value of this function g when x is 0. Then you would substitute 0 in place of x over here. In this case, this does not mean f times 0. This means what's the value of the function when x is 0, like this. And over here, what's the value of the function when x is 1? You would substitute 1 in its place. So f of x is just simply another way of writing y. Okay, let's make our table. So here we have x, and here we have y, or we're going to call this now f of x because now we're in algebra 2, and we have to use fancy terminology. Now I'm going to pick some numbers here, see? And I'm going to find the corresponding y values over here. So let's fill this out. I want to first find out what's the value of the function when x is 0. Now this means what's the value of the function when 0 is substituted for x. This is not f times 0 again. This simply means what's the value of the function when 0 is substituted for x. 0 squared is simply 0. Now this means what's the value of the function when 1 is substituted for x. 1 squared is 1. What's the value of the function when 2 is substituted for x, or when x is 2? And that's 4. What's f of 3? Well, then you substitute 3 for x, that's squared, and that is 9. Okay, so let's write this over here. That's 1, that's 2 is 4, that's 3 is 9. Okay, what's f of negative 1? Which means what's the value of the function when negative 1 is substituted for x? So it's negative 1 squared. Now negative 1 squared is positive 1. How about f of negative 2? Negative 2 squared is 4. How about negative 3? F of negative 3 is negative 3 squared, and that is 9. And I hope that you see that these are symmetrical on each side. Now my axes are already labeled, x and y. Always label your axes. And then let's label some of these points. I like to go by 2's because that looks neater. Otherwise it looks a little cluttered, I think. I'm trying to set a good example for you here, Okay, the origin of course is 0, 0. Alright, let's plot this. Alright, 0, 0. Okay, that's right here, that point over there. Now this point over here, 1, 1, that's over here. And then we have 2, 4. That's 2 going, that's 4 right there. There we have it. Now I think we can connect the dots. Ta-da! See, this is the graph of y equals x squared. And as you probably know from before, this is a parabola. So now we've graphed the parent function. I'd like to make a couple of observations. First is that, as you can see, this graph is symmetrical. In other words, half of the graph is on the right and half of the graph is on the left. And this line over here, in fact, is called the line or axis of symmetry. And the axis of symmetry is very, very useful in graphing these parabolas. And then, the second thing I'd like to suggest to you, this point right here, the point of turning where the graph turns, that's called the vertex of the graph. Now that vertex has this ordered pair in this example. And the vertex of a parabola is typically given a name. Many books give it the name HK, in other words, the ordered pair HK. Now I like to call the vertex Vx and Vy, like this. That is, this is the x coordinate of the vertex, and that's the y coordinate of the vertex. There's no confusion, the Vx implying the x coordinate of the vertex, and the Vy implying the y coordinate of the vertex. So probably the two most important aspects of a quadratic function, of a parabola, is the vertex and the axis of symmetry. In other words, if you were trying to graph parabolas, you better put the vertex in there and you better put the axis of symmetry, otherwise it's going to look quite funny. Now we know what the parent quadratic function looks like. Now this is the basic quadratic function, right? See, what you have to know about the parent quadratic function is that it is a parabola and it kind of looks like this, and it has a vertex, and the ordered pair that corresponds to the vertex is Vx, Vy, and that it has an axis of symmetry or line of symmetry that kind of goes like this. So now let me ask you this. So if this is the graph of y equals x squared, what does the graph of y equals negative x squared look like? In other words, what does this negative 1 over here do to this graph? So what does this negative do to this graph? Well, let's do it again. Let's make the table. I'm going to call this function g of x. Okay, so here I'm going to do the math for you. G of 0, that's negative 1 x squared, right? So it's negative 1 times 0 squared, that's 0. How about g of 1? Now you have to be careful over here because this is negative 1 times 1 squared, and that is negative 1. How about g of 2? That's negative 1 times 2 squared, and that's negative 1 times 4, and that is negative 4. See, it is imperative, it's very important to understand that this square over here only applies to the x. It does not apply to this negative 1 over here. In other words, this can also be rewritten as negative 1 times x squared, whereas the square is only applied to the x and not the negative 1. Alright, so g of 3 over here is negative 1 times 3 squared, then that is negative 9. Alright, let's go on this side over here. Alright, g of negative 1. Okay, it's negative 1 times negative 1 squared, and that is negative 1. How about g of negative 2? Negative 1 times negative 2 squared is 4, and that's negative 4. How about this? Negative 9. And again, you see, these are symmetrical. All right, let's graph this out. Okay, so what we learned from this exercise is that y equals x squared is a parent function. Y is equal to negative x squared is basically the flip of the graph like this, like the mirror image across from the x-axis. Okay, watch. This is y equals x squared. There we have it. That's the parent graph right there. And now I'm going to graph y equals negative x squared. See? It's exactly the mirror image of the parent graph. So what I'd like you to appreciate is that if you have a graph y equals x squared, and if you put a negative sign over here, whether it be -3, -4, so if it's y equals -3x squared, this negative sign will flip the graph compared to the parent function. Okay, if this is the graph of the parent function, what does the graph of y equals 3x squared look like? Well, think of this like this. Would you rather be paid y equals x squared, or would you rather be paid y equals 3x squared? That is if you want to make money so you can do more charity work, etc. Right? Well, of course, you'd rather be paid y equals 3x squared because you'll be making more money. That is, for any given x value, the y value would be bigger. In other words, this graph would be shooting up faster. Right? Let's graph this out. So here's the parent function, y equals x squared. And now I'm going to do y equals 3x squared. Ta-da! See, there we have it. See, it's going up faster. Now, what if we did this? Y equals 5x squared. That would be even faster, right? All right, how about like 50x squared? Oh, it's really fast. But it's still a parabola. Let me zoom out here a little bit. Let's zoom out, see? They're all parabolas still. So this number here, the number before the x, kind of makes it skinnier in a way because it goes up faster. Just think of it like this. Would you rather be paid this, or would you rather be paid this? Because this number goes up faster. Now, on the other hand, how about this? Y equals 1/2 x squared. What do you think? Well, would you rather be paid this, or would you rather be paid this? Of course, you'd rather be paid this because this is going to go up slower, right? It's like your income is like cut in half. So let's see what happens if you graph this. So there's our parent function. Now I'm going to graph y equals 1/2 x squared. Well, 1/2 is 0.5, right? There we go. That's the blue curve, see? It's going up slower. What if I did like quarter instead of 1/2? We would do quarter, like 2.5. It goes slower, right? Now, what if I made this number really small? Oh, it's going up very slow. Look at this. The smaller this number, it's like, your pay is being cut, like, so you're making less money, so to speak. It's going to go up slower. Now, it's still a parabola. Let's zoom out a little bit. See, if you zoom out, it's still a parabola. See, that's the parent function, and this is this new function that's going up slower, correct? Well, what did we learn so far? Well, we understood the parent function, and then we appreciated that if you put the negative thing, it's going to flip the whole thing down. And then we said if you put a number in front of it, like a big number, right, it'll go up faster. The graph will be kind of skinnier because it's going up faster. But if you put a small number over here, like half, like if your pay cut is cut in half, then the graph will go up slower. Now, how about this one? I'll give you a combo. What if we flip it like negative and then 3x squared? How's that? Now this, compared to the parent function, see, this one's going to be flipped. It's going to be upside down. It's going to be an n. So this is like a u, right? So this is going to be like an n, upside down like this, a u, and this is n. So it's going to be an n. And what does the 3 do to it? It's going to be like skinnier, right? It's going to go up fast. In this case, it's going to go down faster, right? So let's see. So there's our parent function. And now we're going to do minus 3x squared. There we have it. See, it is skinnier because it's going down faster, so to speak. And it's flipped upside down. Got it? Okay. Okay, I got one more for you here. How about this? Y equals x squared plus 3. Now, see, this is tricky because over here, the 3 is right in front of the x. And over here, 3 is like plus x. What difference does it make? Now, let me ask you this. Would you rather be paid this, or would you rather be paid this? Of course, you'd rather be paid this because you're getting 3 extra bucks. But you see, that's very different from this. That's like you're getting 3 times your pay. Over here, you're just getting 3 extra bucks, right? So if you got like $100 pay, over here it would be like $300. Over here it would be like $103. Clearly, this is a very different scenario, right? But nevertheless, how do these two graphs compare? How does the graph of y equals x squared compare to this? What do you think? So, let me tell you what's going to happen. This graph and this graph are going to be identical, except this graph is going to be moved up by 3 units. Every single point will be moved up by 3 units, like this. Well, let's graph it out. Here's y equals x squared, and let me do y equals x squared plus, let's see, 1, 2, 3. There it is. See, these are identical graphs, except for the second one is just moved up. The whole graph is kind of like a chess piece. The whole thing is just moved up by 3 units. And if I did like this, y equals x squared minus 5, the whole graph is moved up by 5 units. See, it's over here starting at 0, -5. Okay, so what did we learn so far? Well, we learned the parent function, and we learned what happens if you introduce this negative sign over here. Then we explored this, y equals 3x squared. This graph went up faster, was skinnier. Whereas this graph, y equals 1/2 x squared, this was chubbier because it went up slower. And then I said, y equals x squared plus 3. This was the same graph as this, identical graph, except that the entire graph was moved up by 3 units. Just like a chess piece going up on the board. See, now you can understand why it's imperative to understand the parent function, because you can understand a great deal about quadratic functions if you know this. So if I gave you something like this, y equals -5x squared minus 3, now you should know what this looks like. Okay. Kind of have a feel for what this graph is going to look like. This graph, first of all, will be upside down, so it will kind of look like this. And then this 5 over here, that means it's going to go up faster, right? So it'll go down faster. It's going to be skinnier than the parent graph. So it's going to be skinnier than the parent graph. And this -3 means instead of it going up 3 units, it's going to go down 3 units. So this graph, compared to parent graph, it's going to start out like over here, at -3, and it's going to be skinnier than the parent graph like this. Okay? So let's see if that's the case. Okay, so that's our parent graph. So y equals -5x squared minus 3. Ta-da! And there we have it. See, it's the flip of the parent graph. It's skinnier, so to speak, because it's going down faster, and it's moved down by 3 units, not up by 3 units. Now, the only thing that we have not done here is this. Y equals 3x squared plus 4x minus 5. We have not introduced the second variable over here. Now that's a little bit more trickier. We'll save that for next time. Until then, as-salatu was-salamu ala rasulillah, walhamdulillahi rabbil alameen. Assalamu alaikum.